Dear ladies and gentlemen, my name is Elias and I'm working in the Industrial IT department of Simpelkamp Logistics and Service. We are happy to welcome you today on this webinar, because today we want to answer how artificial intelligence algorithms in the wood-based panel industry can establish virtual hot press simulations. But first, let me introduce you to our technical expert and ProdIQ profile developer, Matthias Heister.
Thank you, Elias. I'm happy to be here, and I'm looking forward to explain how powerful this new tool for our clients in the wood-based panel industry can be.
Great, thank you, Matthias. Now, before we start talking about sophisticated industrial IT solutions, I would like to share the state of the art with our audience. So, how does raw density profile measurement work today for most of our customers?
In order to guarantee the quality requirements of the product, it is common practice to check the product at defined intervals during the production. For that, a lab cut is made or a complete board is rejected from the cooling and stacking line. This test board is handed over to the laboratory of the plant. After a defined conditioning phase, several test blocks are cut out of this board. In the further course of the process, these blocks are then tested in raw density measurement systems. However, this is the state of production from a few hours ago. In the meantime, some things may have changed in the current production and are not considered.
I see. So, some clients have a sort of X-ray measurement device to control the density profile after their press.
Yes, they have to invest a lot of money for such equipment, but these measurements are not very reliable compared to laboratory tests, and more crucially, they have high maintenance costs for X-ray tubes. ProdIQ Profile is able to calculate density profiles every 30 seconds. So it includes online quality control of density distribution inside the final board.
What other advantages does the profile module give to our customers compared to X-ray measurement devices?
ProdIQ Profile is also a simulation tool. This means you can test settings before you change production. This significantly reduces the risk of producing rejects when testing new settings.
Wow, that sounds like we can produce boards digitally. What an USP, and we are the only supplier that can offer such a system in the wood-based panel industry.
Yes, Elias. Our team developed ProdIQ Profile within an exclusive partnership with Professor Heiko Thürmann of Bern University of Applied Science. He has been at Oregon State University and University of Hamburg too. ProdIQ Profile is based on well-known virtual hot press that was developed by Heiko Thürmann. We have been working for about 10 years to make this available to our industry. Now it's ready to sell and provide to MDF lines of our most innovative clients.
That means that Simpelkamp has the most advanced and exclusive collaborations to leading international universities in the wood-based panel industry, and thus benefits on knowledge that we can pass to our clients. Very nice! Before we go further into the technical part of the topic, I would like to mention the key benefits of the ProdIQ Profile system. First of all, you have an online raw density profile control. This leads you to more first quality boards, less waste, and you can simulate your press settings before you actually produce in your real process. Imagine the ways of training in R&D without slowing down your production. And don't forget, saving costs for X-ray measurement devices. So this is a really powerful tool. Okay, Matthias, now let's dive into the technical part. How does raw density profile simulation work? And what does it have to do with artificial intelligence and physical modeling?
How about Mr. Thürmann explaining the basics to us himself?
Yes, I'm happy to explain the physical model ProdIQ Profile is based on. This model describes the physical processes inside a fiber or particle mat during hot pressing. So it calculates the heat transfer, the moisture movement, the densification of the material, and other processes as well. Each of these physical processes could be computed by relatively simple equations But because the processes strongly interact with each other, we had to combine all these mechanisms in a quite elaborate finite volume model. With this model, we are able to simulate many features of the pressing process, such as the temperature in the core layer or the gas pressure inside the mat, and also the development of the density profile. As you can imagine, such a model needs information about the physical properties of the mat, such as thermal conductivity, gas permeability, or parameters describing the compression behavior of the mat. We also call these parameters the rheological parameters. These material properties have been measured in the past for several material types. Now, to apply this model to a new production line, we would have basically two options. First, we could measure all the material properties for the new material used in this line, but this would be quite time-consuming and also quite expensive. And secondly, we can calibrate the existing material property data to fit to the new production line. We choose the second approach, and how it works you will learn later in this webinar.
Thank you very much for this explanation, Professor Thömen. So Matthias, how are the artificial intelligence algorithms calibrating the virtual hot press with the respective Conti-Roll or Custas press?
To be able to start a robot density profile simulation, it needs the corresponding data out of the production line. Therefore, the material flow tracking is used. The flow tracking is very important because these data describe the environment under which the robot was produced. These data consist, for example, of the moisture and temperature of the fibers, but also the pressure distribution in the press, heating circuit temperatures, and many others at the desired time to be simulated are important. In addition to the formation history of the robot, physical properties of the fibers are also needed for the simulation. These properties depend on the material and can therefore be changed by, for example, the material mixture, the settings of the refiner, environmental conditions such as weather, and others. This is a point at which artificial intelligence becomes relevant. The real material properties in the press line are unknown. To adapt the simulation to the physical material behavior in the press, an optimization algorithm is used. This algorithm adjusts the physical and rheological parameters of the simulation. It takes the technological aspects of the pressing process into account as well. This adjustment of physical and rheological simulation parameters is called calibration. For calibration, raw density profiles are required, which were measured in the laboratory. The algorithm uses these laboratory measurements to find the real material properties. It optimizes them until the simulation results are close to the measured laboratory results. So, first step is the calibration of the physical model to the current plant situation and current material properties. With these realistic physical properties and the material flow track data, the actual pressing process can then be simulated. These predictions are then presented to the plant operators as a source of information on the current density distribution.
So in order to run the ProdIQ profile system, we need, in summary, material flow track data like pressures and heating systems, temperature and moistures of the fibers, of course further forming line settings, the lab cuts that are automatically fed into the ProdIQ system, and the calibration of the simulation parameters influencing the behavior of the mat inside the press. And then again the lab data for refining those calibration results. And in the end, we will have an accurate raw density profile simulation. By the way, if you would like to learn more about material flow tracking, you can watch our webinar about ProdIQ quality. The link is either displayed up here or in the chat box. We will now finally have a look into the software. Matthias, please guide our audience through a short demonstration.
Yes, sure. I'm proud to present you our new interfaces of ProdIQ Profile. At first, I would like to show you our simulation interface. The current displayed data is loaded directly out of a simulated lab cut. Here we can see every press and material property that has influence on the simulation and were active as the lab cut was produced. If we now simulate these settings, we can use the following displayed result to dive deeper into the pressing process. With the slider at the bottom right, we are able to follow the complete cycle of the board through the press. The result window will display the physical values and curves associated with the press position. Thus, we are able to follow the development of our density profile, but also moisture and temperature distributions from the press infeed to the final board. So, what do we do now when we want to test new press settings and their effects on the raw density profile? For example, higher pressures during initial densification at the press beginning. For this, we can adjust the pressures to the desired frame system directly in the interface. By clicking on Simulate, the settings are accepted and calculated. The values are then updated in the results window. Here we are again able to run through the entire new press process, but also the comparison of the simulation results is possible. We can now switch between the two simulation results we have made. So we are able to see the results of our changes directly. At first glance, we can see that the density peaks are now much more pronounced and that the maximum value has also increased. The material that is additionally present in the surface layer is now missing in the core layer.
Okay, let me summarize in simple terms. So manufacturers investing in our system will know their current board's raw density profile. And every 30 seconds it gets automatically calculated, and also before the customers change settings to optimize their production. All these settings can be simulated with no risk.
Yes, like already mentioned, ProductCube Profile can be used primarily as an online view of the current production result. The simulation reacts to changes in material properties, such as temperature and moisture, but also pressure and temperature changes and other factors within the press have influence. Thus, the simulation results can be made available to the operator as additional information. This leads to avoiding possible density fluctuations or quality reductions due to undesired density distributions. This makes the production process more transparent and controllable. In addition to the online view, it is also possible to display the historical simulation results. In the so-called historical view, these data are also displayed in comparison to a laboratory import if available. So the quality of the simulation can be immediately compared to the data measured in the laboratory. Due to the fact that this interface also offers an overview of the raw density laboratory data, creeping quality changes or more frequently occurring fluctuations can be recognized. Out of these two views, we can load the currently displayed data into the simulation interface and take a look at the current press and material parameters.
So let me summarize all in all what ProductCube Profile offers. 1. A digital way of producing boards. 2. Information for engineers that seek for press optimizations on the highest level possible. 3. It gives you savings in material, maintenance costs, and time. Having ProductCube Profile and ProductCube Quality at your plant means that you will have full quality observations at any given time. With ProductCube Quality, you will have superior information about your IB, your MOR, your density, your swelling, and so on. And with ProductCube Profile, you will have superior information about your raw density profiles, without any waste. Start simulating your press and get in touch to get your plant ready for Industry 4.0 modernizations, because future is now. Thank you, ladies and gentlemen. Thank you, Matthias. We will now move on to the Q&A section.